Hello guys, how you doing? Once more again, we meet here, and today we are looking at the domain and the range of a function. But basically today our intention is to look at the various graphs, and then we will describe the domain and the range of that. Okay, so the domain is a set of all possible x values, and a domain is the same as the input independent of the horizontal axis, which I call is a horizontal space. When you're checking it, especially from the graph, is left to the right of the graph. And the range is also a set of all possible y values. And in the same way, the range is an output or dependent variable and is in the vertical axis. And when you're checking it from the graph, it's from the top to the bottom of the graph. So when it comes to the interval notation, we'll be using and when anytime we use this, which we call it a bracket, that means that point is included. So especially when we have a quadratic and it's taking U10. So that point here will be included, and we will be using the bracket for that. And if it is like an absolute too, the point that it will touch here will also be included, and we will use the parentheses. Use the parentheses here. The point is not included. That means some of the point is approaching. So approach, we will use that. So if we have here and this n here, you see, is approaching the infinity, we'll be using the parentheses, and all this are here where it's approaching, because we don't know the exact, we'll be using the parentheses. So as we get into the actual example, you understand what I mean, but I wanted to talk about it before we jump finding the domain and the range. All right, so we're going to continue to find the domain and the range of the graph. Okay, so here I will ask you that you're going to use your pencil to follow me. When you're finding the domain, that means we are scanning from left to right. You pick your pencil and you roll it from here. Okay, so you're scanning from left to right. So here we realize that we are in the graph, we are touching, we keep on, it's still touching the quadratic function, is no more. So that's how it is here. But one thing that we have to know is that the quadratic function keep on opening up. It become wider and wider. So with time, it can cover everywhere in the horizontal space, the left and right movement, left and right space, which is the x. So got it. So use your pencil and then roll it over. You're scanning it, and then you see how it covers it. This is what I mean. This keep on going and going and going, going and going and going. So if you keep on widening, then if I supposed to scan, then I will be touching it all the time. So it covers everywhere. And that, how do we write that? That it covers everywhere. It's what we call it starting from negative infinity. Because here is a negative numbers and we call it infinity, because if you keep on going, that's the meaning of that. And this is a positive infinity. And in other words, the negative infinity to the positive infinity, it covers everywhere. That's what we call a set of all real numbers. We can also write it in terms of the x here, which is a set notation to say that, oh, indeed, it's covering the positive and the negative infinity, but is greater than or equals to the negative infinity, less than or equals to positive infinity. Okay, let's look at the range. We said that the range covers the vertical space, which is the top to down. So we are going to use our pencil. So I'm using this here as my pencil. So you have your pencil, and then you're rolling it down. You see, you're touching, when you started, you're touching it. You keep on touching. Now we are at the zero. We are still touching it, and immediately we pass the zero, getting into the negative vertical space. We are not no more touching it. See, no more. It's no more highlighting. So you're rolling your pencil. Now you're touching it. So from zero upwards, it keep on touching and touching. So how do we write that? Remember, this is zero. So here you could say that it started from zero. Here is positive infinity. Here is negative infinity. It didn't come down all the way to the negative infinity. So here you could say that it started from zero, and it moves all the way to the positive infinity, and it's touched. So we're using a closed bracket here, and at this infinity, we didn't see, we don't know the infinity, so we say it's approaching, so we use a parenthesis over there. And how do we write it in other way? We will say that it's a set of all real numbers greater than or equals to 0. Okay, we want to get the y involved, so we write the y, and we write that it keep on going to the positive infinity. It started from 0. We say that indeed it's less than or equals to the positive infinity, but is greater than or equals to 0. In other words, we can forget about the infinity side, and we can also write it as y is greater than or equals to 0, because after 0 it keep on going up. So that's how we write it. Okay, so let's look at one of the absolute function. As we have already been doing, we are going to scan from left to right. So we start from here. We are not touching it. We keep touching and touching, no more touching. I realize that the absolute is opening up, it's becoming big and big. So with time, if we have a bigger space, it's going to cover everywhere. So you'll be rolling your pencil to see. Oh, so you see, this is what I mean. It keep on becoming big, wider and wider. So with time, it's going to cover everywhere on the horizontal space. So as we scan, you see you'll be touching it all the time on the horizontals where the x-axis. So here too, we could say that it's from negative infinity to positive infinity. Okay, this is a negative side and this is a positive side. So in other words, it's a set of all real numbers. Yeah. Then we can also write it as negative infinity. Remember, this is x, so we put the x in there. And then positive infinity is less than or equals to, but is greater than or equals to that. So we are looking. Let's look at the range. The range is a vertical, is a y-axis. So we are going to scan from the y side. Okay. So you have your pencil, you're rolling it from top to the bottom. You're passing it all the time. Immediately you stop at 0. Don't say that it's 2. The 2 is on the x-axis. We are talking about the y-axis, so it's the 0. We immediately we pass the 0, no more. You see that the absolute function didn't actually extend down here. We didn't touch it, so it didn't come to the negative side of it. It's only on the positive, starting from 0 all the way up. All right. So this is what I was saying. Here is 0, because we are looking at the y-axis. Okay, so here you say that is from 0 all the way to the positive side. Here is the negative side. It didn't come over here. So immediately it touch here, it turns around and go all the way up. It's going and going. We don't know where it's going to end. That's the reason why we are using the parenthesis as open. Okay, so here how do we write it? Is what? A set of all real numbers greater than or equal to 0. In other words, it's the y, so we want to put the y here, and it's positive infinity and 0. So it was greater or equals to 0, and it was less than or equals to positive infinity. In other words, we can also write it this way, that it was greater than. If you don't want to bring the infinity part of it, you can also write it this, and this is also accepted. All right, so we want to find the domain and the range for this graph. So as we have been doing, we are going to scan. The domain is left to right. We start from here. We are not there. We haven't touched the graph, the given graph here. Immediately we get to 0, we are touching it. We keep still covering it, covering it, covering it, and covering it. You can see that here now covers that. It started from 0 all the way to infinity. The 0 it touch here is approaching. In other words, we can say that it's what? A set of all real numbers greater or equals to 0. Include our x involved. We put our infinity here, 0 here is less than or equals to, and is greater than or equals to 0. Come to the range. It's from top to the bottom, so we start from the top bottom. We are not touching it. We keep touching, touch, no more. When we get to 0, it's no more. All the way to the negative side, no more. Touch, keep touching. But one thing that we have to be careful is that realize that, you see, as we get here, the graph keep on rising up. So if you have a bigger space, it will rise up to cover the from 0 to the positive infinity everywhere. So this one too is going to behave the same way as the domain. So the domain is also from 0 to positive infinity. Touch the 0, it approaches. So it's a set of all real numbers greater than or equals to 0. If you want to put it in words here, let's get a y involved. We write our infinity here, 0 here is less than or equals to the positive infinity and greater than or equals to 0. It touches 0, it approaches. So here we are looking for our domain. We start from the x here. We are not touching, we keep touching, touch, and no touching. But one thing we have to also know is that from here to here, you see that it keep on widening and widening. So with time, if we have a bigger graph, it's going to cover everywhere on the x. The same thing here, coming down here, we realize that it keep on widening. So with time, it's going to cover everywhere in the x-axis. That's where most of the students actually did not understand it, why it behaves that way. But as it keep on open up, it's going to cover everywhere. So the domain from negative infinity, positive infinity, it approaches on both ends. So it's a set of all real numbers if you want to put it in words. And then when it comes to x, is less than or equals to the positive infinity and greater than or equals to negative infinity. Come to the range. We start from the top. We are touching. It keep on covering everywhere. This is much easier for you to see because it covers everywhere. But the domain, you have to be able to analyze that with time, and we have a bigger space, it's going to cover everywhere. So the same thing for the range is from negative infinity to positive infinity approach on both ends. And it's a set of all real numbers. So all real numbers. Bring the y involved and then put your negative and positive infinity. It's less than or equals to, is greater than or equals to. Let's look at this sine function here. We are looking for our domain. We scan from left to right. We are touching it all the time. You're rolling your pencil, your highlighter, you're touching it all the time. So it covers everywhere. So it's similar to what we have been doing in terms of the domain. So in terms of the domain, here is indeed all real numbers. Okay, we are shortening it, which is negative infinity to positive infinity. We want to bring the x involved because it's a set of all x values. So here the positive infinity, negative infinity is greater than or equals to that, and is less than or equals to that. Now let's look at the range. The range, we are looking from the top to the bottom. So here we see that we are not touching it yet. Immediately you get to this one here, positive one here, we see that's where you touch it. You're keeping touching it in between. The negative one, immediately you pass negative one, you're not touching it anymore. So here realize that it's between a negative one and what, and positive one. So here we can say that is a what, a set of all real numbers greater than or equal to negative 1, but less than or equal to 1. Okay, in other words, it's between negative 1 and 1. You put it here. It's really enclosed between that. Yeah, so if we want to bring the y involved, we write our number here. So here is less than or equals to, and it's greater than or equals to -1. So this is how we write this one. It's -1, okay? I hope you're getting it. Okay, now let's look at exponential function. So you pick this and you're going, immediately you're touching it. Okay, keep touching. It's no more. Okay. But here, let's look at here. You see, it keep on picking up. It keep on picking up. So if the exponential keep on going up, it's going to cover all this side of it. So this one too, indeed, we're going to say that is a set of all real numbers. Okay, because it can keep on going and going and going outside. Okay, so here the domain is a set of all real numbers. This is how some people also write numbers. You have to know all the other side of it, which is from -infinity to +infinity. If you want to bring x involved, is greater than, is less than or equals to +infinity, but it's greater than or equals to -infinity. Now let's look at the y. Let's look at the range. So the range, we start from top here, we are touching it, keep touching, we get to the 0. It's no more touching, we come down here. But here we have to be very careful when it comes to exponential. We realize that it wasn't like the other one that when we were looking at the absolute, it came right here and then it took up here. It did touch the 0. But here, you see that it's lingering. You see that it's lingering at the 0. That means it's approaching 0. It didn't actually touch it and turn over. So we got to be careful with how we write the range. So here we are going to say that indeed it approaches the 0. It didn't touch it, so we cannot use a bracket. We have to use a parenthesis. And then it went to the positive side of it, and that one is also approaching. So we write that. So it's a set of all real numbers greater than what? 0. Here is not equals to of all real numbers greater than 0, right? Which we can write it as 0 here. The y here is less than or equals to, but here is just less than, it's not equal, but which we can write it as this is greater than 0. It's not equal because it didn't really touch it, approach it, it's lingering beside it. Let's look for our domain. We scan from left to right, we are touching it. Touch everywhere. It's covering everywhere. See that? It's covering the small graph that they give it to us, covering everywhere. So if we have a bigger graph, it's going to cover everywhere. Most of the stuff, they will bring maybe arrow here to let you know. But even if they don't, you see the small graph is covering everywhere, then it's going to cover everywhere for the domain. So the domain is going to be -infinity to +infinity. So a set of all, so all real numbers. If you want to bring the x involved, it's less than or equals to, greater than or equals to. Now let's look for our range. So we start from the top. We are not there yet. Now we're in that range. It says that number here, which is 4. Immediately we got to 4, we touch. We keep touching, we touch, and here it did not touch anymore. I did not touch anymore, but we got to be careful with this. This question is a little bit dicey. Remember, since I said if we have a bigger graph, this one could have been keep going and on going. So if that is the case, then we will say that it touched from here, which is 4, and then it's going to be, and here this direction here is -infinity, so it's from 4 and then -infinity, and here it approaches, and here it just touch and turn around, and then you can say that is a set of all real numbers less than or equals to 4. So if we want to get a y involved, here is just less than or equals to 4. This one good, but in case you still want to bring the infinity in there, you can also do that. So here it's less than or equals to, but here is greater than or equal. The two statements, they all mean the same. Here we want to find our domain. We scan from this side. We started, we are touching, keep touching, touch it everywhere. So with a small graph paper that they give us is covering everywhere. So because of that, this is going to be all real numbers from negative infinity to positive infinity. Positive infinity, it approaches. It's a set of all real numbers, so all real numbers. X so it's less than or equals to, greater than or equals to. Now let's find our domain. Let's find our range. So the range we start, we are scanning, we are not touching. We touch it right here, this number, which happens to be 3. Immediately we pass it, no more. Touch it on this little number here. Careful here. So here is the y-axis, and this number is 3. So here, all that we can say is that it's just covering only 3. So 3 here is just inclusive 3 here. In other words, it's just a number 3. So here we can write it as y is equals to what? 3. That's how we can write it. Let's look at this one. We are looking for the domain. So we scan, we are not touching. We have a graph, but within the graph, we start touching it here, this number here, which is going to be 2. So where it touches, it's covering the x-axis within this here, 2 and 5. This one here is just within 2, 2 and 5. Okay, so this one is going to be is a continuous line. So it's a set of all real numbers between 2 and 5, and each side of them is equal. It touches. We can bring our x involved. We write the least number and the greater number, and here we say that is less than or equals to, and here is greater than or equals to. Let's find our range. So the range we start from the top here to the bottom. We are not touching, but immediately we get to the 5, we touch it. Immediately we pass, we get to 1. That was our last touch. We are not touching it anymore. We can also say that it's between this number here, which is 1, between 1 and 5. Here it touch and turn around, and here too is stop there. You see the bubble is stop over there. So we want to get the y involved. We write our big number here, the least number here, and here is less than or equals to, and here is greater than or equals to that. So that's how we can write this one. Okay, so at this moment you can pause and then practice and get your answer, because at this time you have to be really involved with that. So here we are scanning from the X. You're using your pencil to rule. You see you're touching it all the time, touching it all the time on the X side, the X-axis, which is the horizontal space. Okay. So how do we write it? A set of all real numbers, okay, which is negative infinity to positive infinity, which you can bring the x involved, and then right here, and it's less than or equals to, and it's greater than or equals to. Now let's look at the vertical, the y-axis from top to down. See, now you're not touching it up here, but immediately you get to 3. You're touching it, you keep touching, immediately you get to 1, is no more. So it's between 1 and 3. So between 1, 3 is just covering in this vertical space. And now you can say that it's a set of all real numbers between what? 3 and 1. In other words, it's between 1 and 3, and it's enclosed. So you use a bracket, which you can bring the y involved, and then you write your 1, you write your 3. You see that from the 3 it was coming down, so it's less than or equals to, but from 1 it goes up, so it's greater than or equal. Right. Okay, let's look at this last one here. So we are scanning for our domain. You see we are not touching it, but I'll come back and tell you something here. Okay, keep touching, okay. But here we realize that if the graph keep on going, it's going to cover this side of it too. So let's do that extension for it. Is it from here to here? You see, it's becoming too widen. So that means as we come here, it might be keeping widen over there. So it's going to cover everywhere. If we were supposed to scan it, it's going to touch it all the time. So this one too, we are going to say that is a set of all real numbers. Okay, so that's the behavior of the exponential. So once you understand that, so it's a set of all real numbers. That's a symbol for all real numbers. Okay, so here is negative infinity to positive infinity approaching. You want to bring the x involved, so it's greater than or equals to negative infinity, but less than or equals to positive infinity. Now let's look at the y. So the y, we started from here and we are touching it, keep touching, we approach at -1, and you see touching it a little bit is approaching and then no more. As I said, we have to be very careful here. It's approaching, you see it was coming to approach, and then you see that it's now it kind of is on the -1, but I mean from here it was approaching. So unlike the quadratic and absolute whereby it touches it, you see it here is approaching. So gotta be take note of that. Have to take note of that. So here is a set of all real numbers greater than -1. Okay, it's not equal, it's just greater than -1. So -1 here, and then you have positive infinity, and here is a parenthesis, and here is a parenthesis approaching on both sides of it. And then you can bring your y involved, you bring your positive infinity, your -1. Here is less than or equals to, but here is just greater than. Okay, and in other words, we can say it's greater than -1. Tend to do this video to address that. In our next video, we'll be looking at function and non-function from table, from the function, and then from the graph. Please subscribe to my channel if today is the first time. There's greater good content as we are on the field, so we see what the students are going through, and then we come out with a video to address that. Thank you for watching, and be blessed. Bye bye.